An event of international significance in the year 1947 was the striking of oil at a place called Leduc in western Canada. It was the first of a series of strikes that caused the city of Edmonton, capital of the province of Alberta, to become the center of one of the great oil fields of North America. One after another they came in: Leduc, Redwater, Wood Bend, Golden Spike, Wizard Lake, and the rest. And within 3 years, the proven reserves in the Edmonton area were approaching 1 billion barrels and steadily growing. This would be a wonderful boon to Canadians, who had always had to import all but a small fraction of the oil they consumed. However, there was a problem of transportation to be solved, and the Interprovincial Pipeline Company was formed to build and operate a line that was to run from Edmonton to the head of the Great Lakes. Oil would there be loaded into tankers, which would carry it to refineries in Ontario for the benefit of the thickly populated eastern provinces. Construction of the interprovincial pipeline system got underway in the spring of 1950. It was Canada's first big long-distance pipeline. It was completed in record time, and in October of 1950, all of the line was safe underground with oil coursing through it toward the east. This was fine for eastern Canada, but it was of no help to the rapidly expanding economy of Alberta's neighboring province, British Columbia, where several refineries had to depend on oil imported by sea. It was logical that a pipeline be run to the great seaport city of Vancouver from the newly developed oil fields of Alberta. In December 1950, executives and engineers of several of the major oil companies and of the Bechtel organization began studying the routes that could be followed between Edmonton and Vancouver. Both by airplane and train, they crossed and recrossed the Rockies, traversing the main passes. They determined that the most direct feasible route lay through Yellowhead Pass at the western gateway to Jasper National Park at an elevation of only 3,720 feet. The Yellowhead Pass pipeline route would be a little over 700 miles in length, generally paralleling existing railway lines and roads. And so it was that Trans Mountain Oil Pipeline Company was chartered in Canada, and it was given a permit from the Board of Transport Commissioners to construct and operate an all-Canadian line. Canadian Bechtel Limited was designated as agent to design, engineer, and manage the construction. The line would initially serve refineries in the Vancouver area, but later, through an extension across the international boundary, it could also run oil to new refineries in the northwestern states. Through the spring and early summer of 1951, flights between Edmonton and Vancouver were made every day that visibility was good enough, until every mile of terrain along the route was photographed. Engineers studied the aerial photographs and tentatively plotted the pipeline route. To select the best locations in detail, the engineers and old construction men who worked with them had to get close to the ground. They covered some portions of the route with track motors, which took them up and down through Coquihalla Canyon, one of the toughest places on the line, about 100 miles east of Vancouver, where the right-of-way would have to be carved around some spectacular slopes. They did plenty of walking, too. Often they had to take to the hills, as at Jasper Lake. They tramped through the woods, always seeking the easiest grades and the shortest distances, for big-inch pipelines cost more than $100,000 per mile. There was a long section on the western slopes of the Rockies where there was no real motor road at all, only a rough trail through the woods. It was a red-letter day when two reconnaissance parties met on a narrow road overlooking the North Thompson River in the wilderness between Kamloops and Jasper. One party was from the east, the other from the west, and this meeting marked the tying in of the initial overland inspection. The exploratory phase of the project was over. From now on, it would be up to the field engineers and surveyors to set their stakes and precisely fix the locations. But before any physical work could be done on public or private property, mutually satisfactory arrangements for easements had to be made. Local agents were sent out to deal personally with private landowners, to state the requirements, answer questions, and effect settlements. Late in February 1952, clearing of the right-of-way was carried on wherever weather allowed, and where access agreements had been made with landowners, nearly 1,000 of whom, public, municipal, and private, would be concerned. Crews of lumberjacks, inured to cold weather, plied their axes and chainsaws in the forests. All along the right-of-way, a 50-foot wide strip had to be swept clean of timber, whether small or large. All felled timber was valued by registered appraisers, and individual landowners were fairly compensated for it. They were paid, too, for any damage done to crops, fences, or other property. Here and there, in the wake of the lumberjacks, bulldozers not only completed the clearing operation, but also began biting into the soil to grade and level the right-of-way. The time had come to start laying pipe. Cars loaded with pipe joints 32 or 40 feet in length were being spotted at about 140 sidings along the route from which they would be stockpiled. They were 24 inches in diameter, for the biggest pipeline yet laid in Canada. Summer was upon the land. There were trailer camps now at several vantage points, and they were hives of activity at mealtimes. Out of a total force of around 2,500 people on the project, nearly 90% were Canadians. The rest were old pipeline hands from Texas, Oklahoma, and California, who trained as well as supervised the work of their Canadian friends, who quickly gained experience in the complexities of pipelining. Except at night and mealtimes, the trailer camps were almost deserted, for it was out on the line that most of the men earned their pay. At sidings near the camps, especially constructed trailers were loaded with steel pipe. Individual lengths or joints weighed up to a ton or more, and 150,000 tons of them would be needed. The 24-inch diameter pipe came in 7 thicknesses, from 1/4 to 1/2 inch, to be used in different locations according to the pressures it would have to withstand. Meanwhile, the right-of-way had to be given further treatment before it would be ready for the pipe. Where hard rock was struck, drilling had to be done. Powder monkeys placed dynamite into the holes, and the rock was broken up. Bulldozers kept up ahead, making right-of-way on level ground or around hillsides. And then came the ditching machines. Where the ground was soft, a ditcher could grind along, making a slot 3.5 feet wide and 5 feet deep at a rate of 1 mile a day. But sometimes the ground was too soft and too wet for a ditching machine, and then a backhoe was brought to bear. Now and then it got pretty soft for any kind of equipment. And sometimes it got pretty tough. Although the right-of-way traversed rugged terrain for many miles, less than 5% was rocky enough to require blasting. Once the ditch was dug, the pipe joints could be delivered to the right-of-way. After leaving the nearest railroad siding stockpile, the loaded pipe trucks kept on regular roads till they reached their destination, then turned off onto temporary access trails through the woods. Hundreds of such trails had to be opened up, and often existing rural roads had to be improved by the constructors to maintain their supply line. Carefully, one at a time, the pipe joints were lowered to the ground alongside the prepared ditch. In this operation, known as stringing, the joints were angled away from the ditch and barely overlapped to facilitate lining them up later. There were always inspectors around to make sure that the job was being done properly. In undulating ground and wherever the line changed direction, individual joints had to be bent to fit the contours of the ditch. Just ahead of the welders, men with emery wheels powered by portable motors cleaned the beveled pipe ends to ready them for welding. A side boom tractor picked up each joint and brought it into alignment with the one behind it, while a control rod attached to an internal clamp was threaded through. The clamp was maneuvered so as to grip and hold the two abutting pipe ends. A stringer bead was now applied to the joint. This was a critical operation, calling for sureness of touch combined with speed. Once the two ends had been linked by the stringer bead, the internal clamp was released and the next joint of pipe was brought into position. While the line-up men moved forward, hot pass welders put more metal over the stringer bead. Then came the firing line, a team of follow-up welders and their helpers who made 2 additional passes around each seam. The individual joints were literally blended together into a continuous tube, strong enough to carry oil at pressures from 500 to 1,100 pounds to the square inch, with plenty of strength to spare. To help maintain a uniformly high standard of welding, teams of X-ray technicians kept just behind the welders, photographing a representative number of seams. Practiced eyes scanned the film strips, and if any harmful irregularity or defect were revealed, a weld would have to be repaired or a new one made. The pipeliners took small streams in their stride. The pipe would later be buried well below the stream bed. Mobile construction equipment waded right across rivers that weren't too deep, without any snorkel attachments either. After the welders had done their work on the line, a self-propelled machine supported by a side boom tractor cleaned rust and scale off the surface of the steel with a battery of cutters and painted it with a primer. Behind the cleaning and priming machine came another self-propelled and still more complicated piece of mechanism. This was the coat and wrap machine. It performed several functions at once. It flooded the surface of the pipe with coal tar enamel at a temperature of 475 degrees, fed through a hose from a traveling kettle. Then it embedded glass floss in the coating for reinforcement, and finally wrapped the pipe in asbestos felt. Thus, the pipeline was protected from corrosion underground. Among the Rockies, in the vicinity of Jasper National Park, which is a game preserve, the pipeliners were often followed by volunteer scavengers. Discarded sandwiches and other food scraps were never wasted. Continuous sections of pipe as long as 4,000 feet were dealt with at a time where the terrain permitted. For tie-ins, the welders used external line-up clamps. Then the sections were welded together or tied in. Wherever a tie-in was made and wherever the insulation was bruised or incomplete, the pipe was generously doused with hot coal tar and wrapped by hand. The next step was to lower the pipe into its trench. The big tractors with their side booms gripped and held the pipe aloft in wide slings. Then, on signals from the foreman, the operators eased the line down into its prepared bed. Great care and skill were needed for this operation, which had to be done